that first one should be point D, 4 pi over 3. All right, what about the next one? Where is negative 5 pi over 3? The angle, negative 5 pi over 3. Wouldn't that be all the way around here? So the second one is point B. Now, this next one's a little tricky. Negative 3, negative pi over 3. Somebody just told me that if I make that positive, then the angle's going to change by pi. So that would become 2 pi over 3. So that one is point A. What about negative 7 pi over 3? Negative 7 pi over 3 is more than once around, isn't it? So isn't it really at negative pi over 3? So that would be point C. Does anybody have a question about that?
Why is that negative pi over 3?
Because 7 pi over 3 is 2 1/3. So I gotta take out 2 pi, right? So that leaves me with the negative 1/3. All right, now we're gonna change from polar to rectangular. Okay, what does that even mean? What does that mean? What am I looking for? X and Y. And what do I know? Because I say it over and over and over again in my brain. X equals R cosine and Y equals R sine. So then it's easy. What is the cosine of 5 pi over 3? 5 pi over 3 is down here, right? Cosine is 1/2, positive. So my x is negative 1. What is the sine of 5 pi over 3? Negative root 3 over 2. So that is positive root 3. So my rectangular coordinates are negative 1 root 3. Which quadrant is that point in? Negative 1 comma root 3. Quadrant 2. Think about it. Is this point in quadrant 2? Yeah, because when you make that positive, that changes your angle to 2 pi over 3. All the pieces fit together. Now I want polar coordinates. These are the ones, you do whatever you want. I like to draw a picture of this. So I'll draw negative 8, 8. Some of you just make a triangle, and whatever works for you is fine. But putting it in the right quadrant helps you get your signs, SIGNs, and your angles correct. So you might want to consider, as you're drawing it, actually plotting that point and getting it in the right quadrant. Okay, what's my radius then? 8 root 2. And when these two match, we know our angle is pi over 4. But I don't want that angle, I actually want, so 3 pi over 4. So R comma theta. 3 pi over 4. R comma theta. Very, very basic ideas here. Anybody have a question or confused by that? Okay. Express it in complex form. Guys, this, express it in polar form. This is exactly what I just did. The difference is my answer cannot be an ordered pair. My answer is going to have an I in it. But I need the same R and the same theta. So I'm going to draw this one. Over 5, down 5. What's my radius? 5 root 2, square root of 50. 5 root 2. Isn't this angle also pi over 4?
Yeah.
Which means my actual theta is, so my answer is 5 root 2 cosine 7 pi over 4 plus I 5 root 2 sine 7 remember, polar coordinates are r comma theta, the point, r comma theta. Polar form of a complex number is r cosine plus I r sine. Same r, same theta, found the same way. That was mine, sorry. Found the same way, but written differently. Got it? Okay. Now where am I? Give 3 alternate coordinates for the point 5, 3 pi over 4. Well, there are infinitely many of them. So give me one.
-5, -pi over 4.
Okay, are we in agreement with Xander? Is that a possibility? Yes, and specifically, this would be a possibility with r less than 0 and theta less than 0, right? Okay, can you give me another one?
-5, 7 pi over 4.
Okay. What do you think about that one? He changed the sign on r, and instead of subtracting pi, he added it. Perfect. And let's get one more.
5 negative 5 pi.
5, negative 5 pi over 4, you say? Okay, what do you think about that? Notice she didn't change the sign on r. So her angle was coterminal. She subtracted 2 pi. When you change the sign on r, your angle changes by pi. When you don't change the sign on r, it changes by 2 pi. Anybody have a question about that? Okay, F we kind of already talked about today, so let's see if we can remember what we talked about. We have an equation, and we want to know the maximum R. Okay, so where is the maximum R going to happen? It's going to happen when sine is maximum or minimum, depending on if that's a plus or a minus. But let's just look at where sine is a maximum. What is the biggest a sine can be? 1. Where is the sine 1? Pi over 2. So if we put in a pi over 2 there, this would be 2 plus 5, which is 7. Can this R ever be bigger than 7? No, because this can never be bigger than 1. Where does that happen? It happens at pi over 2. Is that okay with everybody? All right. G, consider this polar curve. For which values of theta is f of theta 7? Okay, this is kind of the same thing. R is f of theta. So if we want this thing to equal 7, then doesn't this have to equal 1?
Yes.
Okay, where does cosine equal 1?
0.
It equals 1 at 0. So 5 theta would have to be 0.
Yes.
Would you agree with that? Which means theta is 0. Now, this is a rose. How many petals does it have? 5. The first one is at 0. Right? There's 5 of them. They're evenly spaced, even though some of you, when you draw your pictures, they're not. Remember, these things are symmetric, so everything's evenly spaced. So if there's 5 of them, how far apart are they? 2 pi over 5? Wouldn't they be 2 pi over 5 apart? So if the first one is at 0, Where's the next one? 2 pi over 5. And the next one is at 4 pi over 5, 6 pi over 5, 8 pi over 5. And if I get carried away in our roll, the next one would be 10 pi over 5, which is 2 pi. I'm right back to 0, so I'm done. Here are the 5 leaves, right there. See how easy that was? Everybody good? All right. Consider the polar curve given by negative 10 sine theta. Which quadrants do not contain a point of the curve? Now, you could figure this out by plugging values in, but it would be a whole lot easier if you can remember what that equation is. That is not a rose. What is that? It's a circle. What do you know about this circle? It's centered on the circles around the y-axis, and because it's negative, it's underneath. So a picture of that would look like this. Would everybody agree with that? Okay, so which quadrants don't have any? 1 and 2. Now, see how easy that is if you know what the picture looks like? So even though, again, you're not going to be graphing any of these, your knowledge of what they look like can be very, very helpful. Otherwise, you're going to have to plot some points. You're going to have to stick some thetas in and see which ones work and which ones don't. All right, which of the following have a period of 2 pi? Choose all that apply. Okay, so I'd like you to think about what these would look like. I know they are polar, but think about what they would look like in rectangular if you were graphing them. What do you think? Any thoughts? Well, here's what I mean. Let's look at the first one. What would that look like if you sketched it rectangularly? Oh, we're in trouble. It's a cosine with a period of 2 pi. Would it look like that? What does it look like polarly? What does that equation look like as a polar equation?
Circle.
It's a circle. Where? On the right. Like that? Okay, what happens if we put in 0? If we put in 0, we get 3. What happens if we put in pi over 2? We get 0, so that would be right here. So what are all of these? These are all angles between 0 and pi over 2. Would you agree with that? Okay, so what happens if we put in pi? We get -3, which gets plotted right back over here. Okay, wait a second, now I'm back over here. What are all of these points? Those are angles between pi over 2 and pi. Okay, so I'm to here now. I graphed this on my circle. Okay, what happens if I put in 3 pi over 2? I'm back at 0 again. Aren't I repeating? Are I repeating? Rectangularly, the period is 2 pi. But what is the period polarly? Pi. Because what happens, doesn't pi bring me all the way around? And then what happens after that? I go back around again. So that one has a period of pi. In polar coordinates, it has a period of pi. All right, let's do one more. Let's, and then I'm gonna have you work on that one. You gotta get going. So I'm gonna have you work on this one for homework. Finishing this will be homework. See if you can figure it out. Just letter I. Well, let's do one more together. Let's do, how about, well, we'll just do E. R equals 2 plus 4 sine theta. What shape is that in polar? That one is, say, limason. Let's plot a few points. What happens if we put in a 0? What do we get if we put in 0? Actually, let's go ahead and graph it this way. Midline's 2, amplitude's 4, the sine curve. Okay. So if we put in 0, we put in 0, we get 2. If we put in pi over 2, we get 6. If we put in pi, we're back to 2 again. If we put in 3 pi over 2, we get -2, but remember, that's actually going to be plotted. That would be the point 3 pi over 2, -2. So that's going to be 2 comma pi over 2. And then what happens at 2 pi? We're right back to 2 again. All right, let's see if we can figure out what this thing looks like. I gotta figure out what the period of that is. So I gotta ask myself, does this thing repeat? I don't think so. When I was plotting those points, did I double back over on anything? I don't think so. I think the period of that one's 2 pi. I gotta be careful. That was 3 pi over 2, so this was negative. Something doesn't look right about that. I'm gonna start that one over again. Help me out here, guys. So if I put in 0, I got 2. Okay, so there it is, 0, 2. All right, and then I put in pi over 2 and got 6. Oh, that was up here. That's what happened. That's why that was wrong. Pi was 2 again. No, yeah, pi was 2 again. 3 pi over 2 was, what was 3 pi over 2? There we go. There we go. Yeah, there it is. I had it oriented wrong because I plotted that point right there wrong. Yeah. Okay.
That's the,
So I need to ask myself is, can I graph that without going all the way to the end? And I don't think so. I think I need to go all the way to 2 pi to get all those points plotted. This one, I only needed to go to pi to generate the whole picture. But that one, I think I need to go all the way around. All right, when you spend a little time on those, see if you can figure those out. A couple of them are really easy, a couple of them might be a little more thought-provoking. Okay, here we go. Number J, consider this curve on which of the following intervals is it increasing? Well, what does this look like? What does that look like? Well, it's got a midline at 6. It's got an upside down sine curve with an amplitude of 1, and it has a period of pi. So it's a sine curve. Okay, so it's starting here, upside down, so it's coming down here. Now, yeah, we only go to pi. So here we go. On which of the following intervals is it increasing? So this is pi over 4, pi over 2, 3 pi over 4. Okay, so where is it increasing? Not in here. Pi over 4 to pi over 2, is it increasing?
yeah, I like that.
Yep, so I would say B. Is that the only answer? Or C? C. C? Is that the only answer? Yeah, that's the only answer. Increasing on this little interval right here. Good. Write an equation for a polar rose that has one of its petals at pi over 4. Oh boy.
Here we go.
Oh boy. So whatever is going on, we got a rose at pi over 4. Now, I think there are lots of ways you could think about this, but one thing that we've been talking about is we have some roses that have a leaf at 0. Right? Because whatever that equation is, let's just say, 6 cosine something theta. If this is a cosine equation and theta is 0, then don't you have a rose right there? I mean, a petal right there? Now, if I could go, okay, I have a cosine, so I'm gonna have a petal there. If I'm gonna have another petal here, then there have to be how many petals? 8? Right, if it's pi over 4 away, there have to be 8 of them. And if there's gonna be 8 of them, what would this number have to be right here? A 4. Now, are there other equations that I could write?
Yeah.
Lots of them. First of all, that doesn't have to be a 6, because they didn't give me any. Yeah, it could be any number, yeah, not 0, but yeah. So, but there's one option, do you see that? Are you okay with that? Okay, we'll stop there then. All right, which of the polar graphs would have an interior loop? Which of them has an interior loop? Come on, you know this. C. Describe the graph of R equals A plus B cosine theta when B is 0. Well, wouldn't that just be R equals A?
Yes.
What's that? So like R equals 5. What does that look like? That means if you set up your T-chart, every angle theta, I mean, I don't care, make them up, I don't know, whatever, all the angles of theta would have an R value of 5. So what does that mean? As you work your way around, think of your polar grid. At 0, your radius is 5. At pi over 2, your radius is 5. At pi over whatever, it's 5. 5. What's that going to be? That's going to be a circle, this time centered at the origin with a radius of 5. So in this case, it would be a circle centered at the origin with a radius of A. All right, N, how many petals? 12. How long are they? 8. Angle between them. You said there's 12 of them. So pi over 6. 2 pi over 12. Pi over 6. First petal where? Now remember, doesn't that have to be 1? So if that has to be 1, then 6 theta has to be pi over 2. So it looks like our first one's going to be at pi over 12. So actually first is kind of odd because this is going to be negative 8 pi over 12, which means it's actually going to be at, we're going to plot it. You're not going to plot it at pi over 12. You're actually going to plot it at 13 pi over 12. So your first one is actually going to be plotted down here in this quadrant because it has a negative R, so it's getting flipped over to here. So your first petal is actually going to be plotted at the point 8 comma 7 or 13 pi over 12. Does that make sense to everybody?
Yeah.
Now, you're going to work your way all around. That's just going to be the beginning of it. Now, how far apart did you say these were? Pi over, what did we say? Pi over 6?
Yeah.
So we're going to have one at 13 pi over 12. We're going to have one, you said pi over 6? So 15 pi over 12. By the way, what's 15 pi over 12?
That's just 5 pi over 4.
Okay, and then you're gonna have another one at 17 pi over 12, 19 pi over 12. We're trying to figure out our symmetry here. Anybody figuring it out? Let's see, this would be 23 pi over 12. My spacing is really bad. Where will the next one be? At pi over 12? Because that one is gonna match up with this one, isn't it? And that one's gonna match up with this one, and so on. So what kind of symmetry does it look like we have? I wish I'd been more careful. But it looks like we have symmetry. Okay, so this one's 17 pi over 12, this one's 19 pi over 12. Do we have symmetry across the y-axis? Or this axis right here?
Yeah.
Do we have symmetry across this one? I've got one at pi over 12 and 23 pi over 12. Yeah, we got symmetry all over the place. There. Which of the following could represent this graph? Look at it. It's indented. It cannot be D, and it cannot be C. Why not? C has a loop, and D has an indentation at the origin. It's part of it. So which one is it?
A as a
Why do you think it's A?
Smaller.
Because it goes all the way up to 8. And the one that's gonna go up to 8 is A, because maximum is gonna be 5 plus 3. Okay, so for tomorrow, I want you working on I, seeing what you can come up with for I. And then I'm gonna give you one more review sheet. And then tomorrow, I don't see tomorrow yet. So the next day, the next time I see you, we're gonna get back all of our quizzes that we haven't gotten back yet from chapter 3. And we are gonna go through them with a fine tooth comb, particularly the last one that was not so good for many of you.